In this question we're going to use the ratio test to show that the sum from n equals 1 to infinity of this expression x to the power of n over n factorial is convergent for all values of x that are elements of the real numbers. So essentially all real numbers. Just as remark, the nth term of this sequence is x to the power of n over n factorial, as you can sort of pick out there. But in the ratio test it's actually handy to know what is 1 over un. The answer to that one here is actually just sort of swap the numerator and the denominator, and it is n factorial over x to the power of n. That looks a bit like a 2. Let me just write that again. N. Okay, so off we go. So the next thing we should do is, so we stated that x to the power of n over n factorial that's u of n. So what is u of n plus 1? That is equal to x to the power of n plus 1 over n plus 1 factorial. Okay. Now, just as a few remarks, x to the power of n plus 1 is equal to x times x to the power of n. N plus 1 factorial is equal to n plus 1 times n factorial. Okay, so that is going to help us a bit. So we can rewrite u of n as x times x to the power of n over n plus 1 times n factorial. Okay. So the actual ratio test is as follows. So the limit of as n approaches infinity of u of n plus 1 divided by u of n. Okay, that's why you would sort of invert u of n. You have 1 over u of n, so you can correctly you just multiply those two terms. What we have here, that is the limit of as n approaches infinity. Now what was n plus 1 there? U of n plus 1. X times x to the n over n times n plus 1 by n factorial. Okay. So you can sort of say we're multiplying u of n plus 1 by 1 over u of n. So let's go back here. We have n factorial over x to the n. Okay, so loads of terms here will cancel out. For example, the n factorial's term cancel out. The x to the n's cancel out. So what we have is the limit that is equal to the limit as n approaches infinity of x over n plus 1. Okay, so now all we have to do is evaluate that. Okay, in this situation it is best to divide by the highest power of n. Now just as a quick remark, this expression is in terms of n, so we're going to divide by the highest powers of n. So that is equal to the limit as n approaches infinity x over n plus 1 times 1 over n. And that goes to 0 because we're dividing by a number that is approaching infinity. Likewise that one. So what we have here is 0 over 1 plus 0, which is essentially just 0. So the answer, the limit of this one is 0. Now the test for convergence, is this less than 1? Is this less than 1? And the answer is yes. Okay, so that means the series is convergent because the limit as n approaches infinity of u of n plus 1 over u of n is less than 1. Okay. So that's the answer to that one. That's the ratio test, a simple ratio test question.